I appreciate all of you. So today we will talk about Postgres and the constraint system of Postgres a bit before we enter like what is actually new in the 18 release. There was also 5 days ago, Postgres 19 released the beta, first beta. So my presentation was looking to future a bit like what changes will happen. So it's now more like my predictions are kind of more clear, and we'll talk at the end of the slides basically what's coming for after 18 as well. The agenda is like this. We will look at the PG constraint catalog to understand how constraints work roughly, and some things that I wanted to mention because they are not really known. But the rest, like temporal keys, not nulls, and not enforced, and some improvements, they are specific to Postgres 18. Why they are maybe particularly important? Because some of them are new paradigms that are introduced to Postgres that were part of the standards for a long time, but Postgres is acquiring them recently. That's why I organized this talk that we could talk about them. And who am I? I am from a company called Zeta. I do product there. I have a colleague in the audience as well. We do Postgres. It's modern Postgres. It's normal Postgres, vanilla Postgres, but on underlying we have the separate compute and storage. So we do copy and write branching, scale to 0, some modern functions. And so we can scale instantly. In a way, it's faster. You don't pay for the storage, you just pay for the compute and so on. So it goes. But if you want to talk about Zeta, we can talk later. I am recognized as a Postgres contributor. I am in the community for a long time, contributed different ways. If you come to Prague, that's where I live, please come and talk about Postgres, or just visit. But we run every month Prague Postgres meetups, and I'm running them. And I am Turkish originally, and I have a community of women developers in Turkey for 13 years. And for the last 4 years, we just started an AI conference called Diva. And if you want to visit Istanbul, another reason to come and talk. We are not like this regular AI conference. We care about the inclusive AI for good, on top of the ML engineers getting together as well, research and industry together. But we look from a bit more human perspective to it. So it's not your regular AI conference. Anyway, so yeah, I work for a while. Let's skip the past. And before we go ahead, it's customary to define the basic thing that we will talk. It is what is a constraint. So these are the rules that you can attach in your columns in your database, and they enforce something that you wanted to check. Let's say you have a numeric data type, but you wanted to have only positive values, right? You have to write a constraint to make sure that you only get positive values. If not, you just error out. And this is simply it. And we will talk a bit more now. So there is the PG constraint catalog in Postgres. If you are new to Postgres or maybe new to this terminology, a catalog is a system table that is keeping your information about your own tables. Let's say, for example, you have your own application data, like, I don't know, tables like orders, products, I don't know, users and so on. And Postgres itself has metadata about this data, like what's happening in the tables, what are the column types, let's say. And in this case, for PG constraints, it's about constraints. So it keeps about, constraint name, constraint type, all the information about, are they attached to a table, are they attached to a domain, how they are interacting. So there's lots of information that database stores. So these are catalog tables, like normal system tables. You can actually see them through the catalog schema. And PG constraint is one of them. And this first part of the talk, we will look at PG constraint documentation, this paragraph, and see what this paragraph can actually tell us about, constraints. The first one is very simple. It says that this catalog stores check, not null, primary key, unique, foreign key, and exclusion constraints on tables. And basically, these are all the types, and I want to show you an image here. So there's another way of basically looking at the constraints from the perspective of a catalog, is that different constraint types map to a different type of constraints. And the last two and the bottom, they are a bit different, like exclude constraints, not much so known, I feel, and constraint triggers, totally unknown, but we will talk. And up until Postgres 18, if you looked at this definition here, you wouldn't see the not null here. And recently, not null became a proper constraint, so got this entry here. And we will talk about this block of changes too, because not null easily worked in Postgres 18, and it was a very long development time, so it might seem small, but it's big for Postgres community, not now becoming a proper constraint. Okay, so the second sentence, by the way, if you want to stop me, you can stop me anytime. If something that bugs you, we could just talk about it, but I have so many slides, so I recommend to wait until the end. Yeah, the second sentence, column constraints are not treated specially, and they are equivalent to table constraints. So what does it mean? So first, if I'm looking at this as a user, for me, the way that you write the SQL is different, but they are internally treated the same way from the catalog perspective. If you write a query like this, let's say in the products October table that I'm creating, if I write the check price, more than 0, then this is a column constraint because it's right after the column definition. And if I put it after the columns are listed at the end, that makes it a table constraint. One difference is that with table constraints, you can have more columns involved in this constraint. That makes a table constraint. But internally, which I will show now in the next query, they are same. So to prove you and also show you how actually this catalogs table is easily queried, I made a query. I use PG constraint catalog that we discussed that stores information about the constraints, and I join it with the PG class. That's where all the data, like all the table-related information is stored. So I join them together, and I look at the tables that we created, October products and November products, and I want to see how it looks like. And what I query back is like what I return is like table name, constraint name, and the constraint type, which we will see. And the definition of there's the constructed function there, pg get constraint def to see how the constraint actually looks like. Anyway, this is not important, but just for a reference, just to point that they look the same. So when you look at it, you see which table that they were attached to, which type they are. They are both check constraints, and this con key here is pointing to 1. That means that they were both attached to the first column. So if a table constraint, let's say, have more, then it will be like 1, 2, 3, or something like array of numbers. That will be the only difference, but the way that is defined internally is the same. So that's what the sentence was referring to. They are same things. And the next sentence, it says, user-defined constraint triggers created with create constraint trigger also give rise and enter in this table. So we know what are constraints, we know what are triggers, but constraint triggers, and I asked them into many Postgres conferences that I've been last year, like, how many people know constraint triggers? Not many. Because you, as a user, you don't really need to know constraint triggers because actually they were meant to be used internally, how Postgres handle the foreign key checks. Because when you create a foreign key constraint, they created constraint triggers to actually make the foreign keys deferrable. So to use this mechanism as a user, you can use it. So when you create, if you write it like this, instead of create trigger or instead of create constraint, if you just say create constraint trigger, you can benefit from this mechanism. I don't know how many times you might need this, but it is there. What separates, like let's say philosophically, what separates a trigger from a constraint is that triggers fire immediately. So they can be triggered after or before or instead of actions. But for constraints, you can actually, with set constraint command, you can decide when this can be run. So you can actually delay this until the transaction commit time. That's why the deferrability concept is important for a constraint. So that's what's the benefit of, I think, or nuance here when a constraint trigger, what makes it different than a normal regular trigger. And of course, there are some restrictions that comes with it because it's kind of behaving like a trigger, behaving like a constraint. You can, even if you defer this though, the second thing, when conditions are immediately evaluated. So you can't get around it, even if you have the constraint deferred. And they need to be after triggers. They can't be before or instead of, because how a rule works, like there's a rule and you have to check this after this thing happening. So you can't really do a constraint validation before. And they are row by row. That's why you need to define them as like for each row, because normally for normal trigger creation, you can do for statement level as well. But for here, you have to check each row as how the constraints are designed. And yeah, you can't apply them to foreign tables or something. They need to be plain tables. Anyway, these are details, but just a concept. And if you are really interested in the differences, because actually it teaches a lot, when I was looking at it, the behavior of MVCC is different between how built-in constraints are and versus how this trigger constraint is. Built-in constraints have more visibility to what's happening underlying in the isolation levels, but here constraint triggers don't have that much of luxury, let's say. That's why, if you are interested in it, I linked a blog about it to see what are exactly the differences if you're interested in it, but it's too long. It could be a topic of its own, a talk of its own. But what I like is, like, if I remember constraint triggers now, I would refer to it as a deferrable trigger. They are like trigger mechanisms, but you can defer them. And that's the term that I stole from a friend, Lawrence, and I keep using it. Okay. And this brought us to the last sentence. It says, check constraints on domains are stored here too. What is domain? So again, like, this was supposed to be about constraints, but we talk about a lot of things that, I don't know, they're not really unknown. So let's see what is a domain. Apparently, you can add constraints on them. So these are custom data types. So you have a base type. In this example that I make is a text. So you are just saying create domain something. The base is like anything that you want, a base type. And then you can add constraints on them to build this type that you created. And then it's simple. I made an email address domain, and I check this regex here. So when you use now, you can refer to it as a normal data type. The email could be the type that you created, this domain you created. And it works. And of course, this is a bit tricky in the implementation side for Postgres, and because it's not really, explicitly showing what's happening behind. Because when you look at email address type, you don't know what type of thing's happening behind. So it's a bit tricky. So they always, now that I know about domains, I always read the commit messages, and like domains are always treated specially. You have to consider them, so they're a bit of like, out of norm implementation. But it's useful. When I think about it, when I seen this before, I was working for maybe 6-7 years ago for a very big company who was doing Postgres distributed. And there they defined lots of these domain types specific for their use case, and it was useful for a very big payment system provider. So I seen that is actually useful, but I don't know, like pretty much many data types cover this with normal constraints, so like maybe depends on your use case. But it is used in the real world. Yeah, I also wanted to show how you can query the catalog tables in terms of like checking this domain constraint. So instead of last time we connected PG constraint catalog to PG table catalog, but now we do PG types because they are actual types, right? So I connected them, and documentation was saying that you can see the check constraint specifically. So I make it like it should be constraint type check, and con type ID is like non-zero. That actually means that it's a domain that is attached to a domain, this constraint. Otherwise, if it was other value, then it would be attached to a table, apparently. So then when you query it, you can see the domain definition, and you can get more information about it. I think it is cool. It's nice to, see the differences about when you think of a constraint, where it can take you. So that's why I wanted to have this short demo before we actually go for what is in the newest releases. Okay, so the intro part is over. Now we will talk about exec features. So let's see. Again, this is like I actually summarized some of the main features commits that went into Postgres 18 in specific context to the constraints, but there are a lot of stuff, and you don't need to read it. I just put it so that like how much effort goes to Postgres or any software that we are probably using in terms of maybe for us small features, but it actually impacts a lot of users, a lot of use cases, and we will see main ones. The first one we will talk is temporal keys. So this is the big thing, I think, maybe biggest thing in terms of the constraints that is added to Postgres, because Postgres is like, relational database. For us, temporal model, people were having this use case before. There was like people building like a temporal model using Postgres, but it was not, supported in a way that native syntax that could support. And now we have it. So we will start with that, and we'll continue with the later features. But before we go back, like the temporal keys itself, I wanted to step back a bit and see what makes a database, temporal database. So there are like this criteria, like 8 criterion, that makes it or not make it a temporal database. The first one is like this database has to have a period data type, and this data type could be unbounded. It could go to infinity or forever. So for this, we have range operators in range types in Postgres. So we have, I don't know, date range, TS range, TS-TZ range or something. So we fulfill this. We don't have the specific period data type that actually SQL standard has. We don't have it in Postgres, but let's say we fulfill this need. The second one is like ability to define valid and transaction time and temporal relations. So valid time and transaction time, if you don't know the temporal model, something unknown. Basically, if it's something referring to a valid time, it is the time that is happening for that application, that matters for that application time. And I will show you with the examples. But it's related to what you know of, the fact that you know of. For the system time is like a transaction time, it could be referred as well, is what database is knowing. So it's kind of like, consider like you have like audit kind of tables that every transaction that you have is kept natively in the database. For Postgres, we don't have that. So that's why we don't have the temporal relations. I put partial sign there. We have the valid time concept, but we don't have the system time concept at all. That's why it's partially supported. But we will talk about these different ways of thinking time semantics later. The third criterion, then it is we don't have it, right? We don't have system maintained transaction time. We will talk about all this temporal primary key, unique key, and foreign key, which will be the main topic after this. And the rest, the one under, it says update and deletion of temporal records with automatic splitting and coalescing of time periods. So for Postgres 18, this was for sure no. But for Postgres 19 in beta, I just seen it 5 days ago, it was announced. I don't know if it will make into the proper release, but anyway, so we have now, I would say, partial support for this because there are new commands for update for portion of delete of portion of something. That's the exact syntax, I don't remember, but you can do this now. So you can actually update the records over a period in the temporal data set and delete them too, which was not possible before. But you can't do the correlation, you can do the splitting, which I will maybe talk later if we have time for the Postgres 19 part. But it's already improving between one release to another. And the last two, I don't claim to understand, but apparently having range operators kind of fulfill this, and we have that. So that's covered. Okay, so again, I wanted to go back to semantics of time because I think if we just put a simple query, it is much more clear than, talking through the theory of it. As I say, like for normal relational model, how we were treating time, right? Let's say a salary of an employee is updated. We only keep the current salary. We don't really build the systems as like, okay, when this change was actually effective and when this was change made, and when I query an employee, I don't really see, overall time of like what this value of salary was changing. So if you design the data with a concept that the time is always there as a dimension, with a, this range period mind, then you can actually track these changes, let's say in salary in the first model, right? If the employee is like first employee, and the validity period is like from January to June, and from June to infinity, then the salary changed. Now it will make me see when this was changed, like what was the salary at this time period and so on. So this will allow me to actually have the track of the time. That's why the temporal model treats this time as a whole proper dimension. So when you design your primary key now, you don't only have the employee ID, but you also attach the period together. That is, and the concept that for this one employee, at different time periods, you can't have different, like for the same period, you can't have different salaries. So that brings the without overlaps concept. So they are not overlapping for this business key together. And business key is made with basically together, employee ID and validity period. We will see that later. But yeah, and the transaction time, to explain, for example, if your salary was effective from June 1st, but the HR was making this change, let's say June 10, that would have been the transaction time when this actual information entered the database. So if we had this information, the transaction time of this change will be my system time that I keep as a database, and we lack of it. Okay, and I really like this quote from Boris Novikov when I was hosting the Prague Postgres meetup in last June, I think. He came, and that's the first time I think about thinking of temporal models, because his presentation was prior to these changes, and so writing a temporal constraint was much different. So it was like now you could see that it's how much easier now with all the support, but before, how they were building these temporal keys is like they are using GIST extension. Anyway, the underlying mechanism for the temporal keys is also GIST index, not like B-tree indexes. And they were using exclusion constraints to do what is now done with regular temporal keys. So what he said that they're like queries to a temporal database return facts that were, are, or will be actual at time that may differ from current time. And this concept is not a concept that is really taught for the regular relational databases, and so the model is different. So each data row has to have an associated time period, as we've seen, and they need to be like closed and open, so they never overlap. And querying is different, editing is different, deleting is different, all different. Okay. I don't want to go too much to the temporal, but just wanted to show one query exactly. So for our case, like when you want to say, okay, which salary was valid, it's become very simple, right? And you can just say, if valid period contains this date in the 15th of March, then you can see it now. Very, very simple. You don't need to go hoops around it. And if you wanted to make sure now that an employee cannot have two salaries valid at the same time, which is reasonable, then you have this new notation of like normal primary key normally, right? This is the scalar part of the key, employee ID, and together they make this now temporal key, and this is the valid period without overlaps. So without overlaps always have to be in the second, the last basically column, and this type needs to be a range type or multi-range type. So once you have this syntax now, it will very simply make sure that you can't have the two salaries valid at the same time. I think it's really amazing. Employee ID is identifying the employees, right? And the validity is now the period that the fact is valid. And the fact that we are tracking is, in this case, is salary. Okay. So we have for this, for primary keys and unique constraints, I wanted to put it here to just, again, to remind you, if you want to benefit from these features in Postgres, you need to create this extension, B3 GIST extension. Maybe you were already benefiting from GIST, but specifically for these features, for this type of keys and operators, you need to have the extension. And simply, let's say, if you have a rooms table and you have bookings, right? And it is like you can't reserve a room for the same period differently, right? So that's why I thought a simple example would be like, yeah, room ID is like I took as a scalar key, and during is the period that I'm restraining without overlaps. And then let's see if I enter here. I'm entering two rooms, blue room and green room. And for the blue room, I'm entering two bookings for the same day from 10 to 11 and 11 to 12. And then I'm trying to basically see the violation of this constraint. I'm trying to enter a value that is like, will conflict with the first value because it's from 10:30 to 10:45. It explicitly says like, hey, you can't do this. It conflicts with the existing this and this. It's very simple. And now, we can just set this up very easily. One minor thing, it doesn't support empty ranges, which doesn't make sense anyway. An empty valid time doesn't really mean anything, so this is not supported. If you wanted to enter an empty value, it doesn't work. Of course, if you want to enter for the same period for the other room, that's nothing stopping that, because then you can have another room ID and different periods, totally fine. And the summary, I wanted to show you how it was done before, as I said. So if you were using exclusion constraints before, you were doing this exclude using GIST, and for room ID, it was checking the equalness, and for this, it was checking the overlap range during with. And now we don't need to go through that at all. We can just write proper primary key or unique key That will be much easier and elegant. And when you think about the referential integrity, this was one of the criteria. So you can't really build something only checking for primary key and unique key without having the referential integrity in the database if you are using the same model. So you need to have this temporal referential integrity with foreign keys too. But normally, with normal foreign key, how it does, like for every referencing row, there is a reference row with the same key, right? That's how we do this integrity. But for now, we can't really do an equality match. It needs to have like, basically, all these rows needs to be valid over time varies, which are both ways. And this integrity must hold during this period. So it's not a single point. There are like ranges of the matching happening. So it's like, that's why the whole, for every referencing row now, there needs to be this reference row for existing for valid or for all this entire period of what we are checking. That's why the period clause comes here. As you see now, if I want to define a foreign key, let's say a booking availability table, that, you know, rooms needs to be available for the bookings to be valid. So then have this room ID and period during, and if it's referencing, again, room availability table, then room ID and period also needs to be available for that period, right? That's why, but the opposite writing, because without overlaps, it was kind of after. For the period, it comes before, but in any case, period is very self-explanatory. For these periods, the referential integrity must match. Yeah, of course, it is not a regular foreign key implementation, right? And so that's why we don't have every action supported, like do something on update, on delete, cascade. Those are not supported yet, maybe later on, but they became quite hard, quite quick. Okay. All right, so this is the temporal part. Now we are coming to do another new, I think, set of changes. The introduction of not enforced concept. So we have the not valid concept for very long. So, and the reason for it is that when you create a constraint, you don't want to validate immediately, because those things end up like in the scan, table rewrite, that means lock. You want to avoid lock. That's like one of the most important things of managing a database, to make sure that you have only lock contention in the minimum as possible and in a shorter time as possible, in the lower level as possible. That's why not valid is amazing. So if a statement has, let's say, when you are creating a constraint and when you are adding a constraint with not valid, and then you have the chance to validate it later, this can cost differently to you. That's why it's really important concept. And not enforce is a way, like if you have not valid for a statement, not enforce is actually taking it a bit more further, because it's actually not enforcing that constraint at all. So it's kind of like an informational constraint. Maybe in the future it will like impact on the planner and optimizer decisions, but we are not there yet. But it is like kind of a signal, right? That's what the intention of the database is. This constraint is created. The intention is maybe it will be enforced later. So that is I wanted to create for an example how you can make it a check constraint create with a not enforced. I use the same constraint that I created before, and I can make it not enforced. And to be able to see this now, you can check again in the catalog in the con enforced flag. And since some of the constraints now allows it actually change the enforceability of it, you could track it from there. But for Postgres 18, if you wanted to change this to not enforced to enforced, you can do that, but you had to drop the constraint and create again. But with Postgres 19, they made it for check constraint that you can actually change the enforceability without dropping the table. It's already getting better. But for check constraints not enforced, it doesn't really make so much sense to me. But what it makes sense actually is for the foreign constraints. Again, why it makes more sense for the foreign constraints? Because when you created a foreign key constraint, there are also triggers created to have this data integrity. And if you create it as a not enforced, that means that you actually don't need to create this integrity checks anymore, which is great because then you have to go through all these checks immediately. And if you make it not enforced, that will give you some time. Maybe you can enforce them later on, type of thing. And okay, so if these checks are not created, and then the constraints that are coming, right, will be marked as not valid. This is great. And if you wanted to change this enforceability, you can make it like not enforced to enforced, And then this action checks and all these triggers will be created. But the things to be mindful of, when you change something from enforced, not enforced to enforced, then you also force the constraint that are attached to it as valid. That means that there will be validation scans happening. So it's something to be mindful, like when you change this, it's not a simple flip. Exactly. And you can also do the other way around. If you wanted to have something that you already enforced to not enforced, you can also do that, but then the triggers that are there will be dropped and the constraints that were created will be marked as not valid. I think this is a good flexibility. This is always, giving the user to choose when they want to do these operations are a big benefit. Okay, the rest is like a bit, I just put it here because if you plan to upgrade to Postgres 18, collations might be a problem because now there's a rule that if in between the primary key and foreign key relations, if they are using deterministic collations, they need to both parties need to use the deterministic collations. If they are not using the deterministic collations, they need to use the same non-deterministic collations. That's important if you plan to upgrade Postgres, otherwise it's not a big change. And this is the last part of the big changes, as the time is kind of getting to almost to an end. Not null changes. This is the really big thing. Now we have, as we see in the con type n, referring to not null. This is coming. And what makes the constraint different? Because before it was part of PG attributes catalog, where the column information is kept as a flag. But having a full-fledged constraint is that it gives you a chance to, you can name these constraints, you can drop these constraints, and actually change the deferrability of it. Like now you can have the proper inheritance, you can decide when you want to, if you want to defer this or not, and it makes the whole different story having this as a proper constraint. And these are, the details that you can come back to it later, but I'll point it out the important things here. So the way that you use it is like, now, since we have the not null properly, we have not null and not valid. So before, when you add not null, it was a costly operation because it need to have the check immediately. So to be able to avoid it, what we were doing is that for adding a not null, we didn't add like set not null immediately. We were adding a check constraint as an invalid, and then we were actually fixing the nulls with a normal DML update, because it's a different level of log, and then we were invalidating the stuff. So we were having a loop around so that how we can make the, avoid all this hard logs. Now we can just do as not valid and then validate it later. And what is the point of having something added not valid? Maybe if you didn't think about this before, the moment that you had the not valid constraint, it is valid for the new event. So if you are inserting new data, those will be enforced because this constraint is there already for the new inserts. But for the existing data, you don't need to check. And this comes with the validation scan, and they both have different levels of logs. So that's why it's important, if you can add something as not valid, it's a big benefit to you, because you don't need to rewrite everything at once. So you can actually, avoid this stance. That's why it's very important, if you have the not null properly, if you want to add now, you can just add as a not valid and validate it later. And this behavior is stored in the con validated, in the PG constraint catalog. And for dump restore, there is nothing much changing, so you don't need to worry about anything for upgrades. And inheritance, it behaves the same as like enforced, not enforced inheritance. So the simple logic in Postgres constraint inheritance is that if the parent is valid in something, you can't keep the child invalid, kind of. This logic works. So if you look at, for example, the second case, inherit to no inherit, so if you have a partition, like a parent partition table, let's say, and the children table, and if you want to drop stuff from the main thing, and you can drop that constraint, the new children will not inherit that because it doesn't exist, but we don't touch the children's constraints. So that's why it is like, they became like children. Con is local false, and the parent is like, maybe this is wrong. Doesn't matter, but it is that like the child starts to, if you want to inherit from the children itself, you can inherit that, and you cut the ancestral line, so they behave the way that they behave, but the inherited table can drop the constraint. Okay, another very important thing, if you have lots of partition tables, Now it is possible to have not valid foreign keys on partition tables itself. So when you create now, when you create a foreign key, let's say on the main table, partition table is the top table basically, you don't need to worry that all the children will be validated at the same time. Now you can do per partition validation, again for the reasons that you actually limit the scope and the log contention. And then, if you want to have the same old behavior, you can also do in the top level validation, but this is up to you. I think this was something that was mistakenly not allowed before. So it was not, Postgres was not allowing drop only from the partition tables because it was I think a symmetrical issue. Because they thought you could actually remove some constraint from the top level and you don't touch stuff in the child tables as we discussed, but this was not allowed before. Now it is, because you can still drop the constraint. It doesn't matter if the other kid tables, child tables have it, they can keep the constraint, but they can't, new ones will not inherit that non-existing constraint. So this was, but of course, you can't really add a constraint and don't expect this to be inherited. So this will be always basically add-only option. This restriction will remain. You can't really add something and you don't expect it to be inherited if you are in the partition table. So this still stays, but drop only was a mistake and now it is fixed. Sorry. Okay, we had actually time now. We have 2, 3, 4. For talking about what's coming for Postgres 19, it was on June 4, they released the beta 1. I don't know if it will all go, but there are good stuff. So the first one, I put it on the top because it's very related to our temporal topic. Update, delete for portion of. So this was, if you remember the criteria that I was saying it's not supported because we don't do this. But now we can actually. So we can actually do native update and delete for the temporal valid time tables, they call it, because Postgres don't have the transaction time. So now, how does it work? That let's say, I wish I had a query for that too, because I thought I can't have that much time to it. But anyway, so let's say you wanted to update a data in a period. So what Postgres does is actually splits this time period. It updates the whatever is necessary and introduces a concept called temporal leftovers, sorry. So it keeps as a row and another row, at least one row, to keep all this splitting automatically. So you don't need to worry about it anymore. So if you have a period that you wanted to upgrade an information, let's say a salary was, 5,000 and 6,000, and you wanted to update a bit of the 5,000 period to some different salary, you can do this now. And Postgres will handle the rest of the splitting this data periods reasonably. Will first, update operation will run, and there will be inserts to keep this period sane. So I think this is really good and important. And there are things to have for example, the one under alter table, alter constraint, not enforce check constraints, which we talked before. We had to drop the check constraint if you want to change the enforceability. Now you can just do it easily. And the third change, what does it say? Alter table column set expression to succeed on virtual columns with check constraints. Yeah, so apparently if you have a expression that is involving virtual columns, if they were part of a check constraint, you were not able to do this. Now you can actually do it. It's easier. What else? They reduced the log level for this operation. As you can see, the log level improvements are really important. So that's why when people ask me, should we really upgrade our Postgres that is running perfectly? You are maybe missing stuff that you might not need to deal with it if you upgrade. Of course, maybe not upgrade to the beta release, but when you upgrade, you automatically get all these improvements. So for this operation, for example, alter domain validate constraint, it was not matching the same log level as alter table validate constraint. So now they matched it and they reduced it from share log to some lower share access log. So it's good. What is another thing that is having a fastpath they added for domains? Again, there was a table rewrite happening. If you, I think, what was it? Addition of columns based on content constraint usually. Yeah. So now it is not requiring a table rewrite if you wanted to change the columns that as part of domains that are part of a check constraint or something. So also getting better domains. Yeah, there's a lot of performance improvements for pouring keys. That patch was really big, so I'm happy about it. And what is very, very important that all this information that I had for temporal tables, I curated from all these temporal models and papers and stuff. There was no documentation about it. Now, there's a really good documentation, actually, much better explaining than what I explained to you. And there's a glossary, so you can actually see all these terms that we discussed. Yeah, so I think I really used all my time. Yeah. Thank you. Danke. And I'm really happy that you guys, girls, everybody, folks, stayed. Yeah, I hope you liked it. Thanks.